Hello everyone, happy to see you here. Welcome back to my channel. Hi Mathematics. Today we have a very interesting question: x cubed minus x squared equal to 48, and we need to find our x. If you have your solution, your answer, you can also write your solution down into the comment section and then we will check your answers. Okay, so let's start. First of all, let's write this 48 on the left side. As a result, what do we have? We have x cubed minus x squared and minus 48 is equal to 0. Right now, let's, instead of this 48, let's write 64 minus 16. Okay, as a result, what do we have? X cubed minus x squared minus, instead of this 48, let's write 64 minus 16. 64 minus 16 and equal to 0. What are we going to do next? Of course, let's open our parentheses. As a result, we have x cubed minus x squared minus 64 and plus 16 equal to 0. But if you look closely, 64 and 16 it's a great values for us, because 64 we can write as 4 cubed. Okay, 64 is equal to 4 times 4 times 4, so this is equal to 4 cubed, and 16 is equal to 4 times 4, so we have 4 times 4 equal to 4 square. Okay, so we have 4 square. So instead of this 64, let's write 4 cubed. Instead of this 16, let's write 4 square. As a result, what do we have? X cubed minus x squared minus, instead of 64, 4 cubed, and plus 16 equal to 4 square. 4 square equal to 0. Okay, if you look closely, we have four expressions. The two of them are like cubes, so x cubed and 4 cubed, and we have two squares, x squared and 4 squared. So let's group it, okay, because we have x cubed and 4 cubed, and we have x squared and we have 4 squared. So let's group our cubes and let's group our squares. So as a result, what do we have? X cubed minus 4 cubed, and we have minus, we can easily write x squared plus 4 squared, but we write it in parentheses, so we need to write x squared minus 4 squared, okay, equal to 0. When you open parentheses, everything's going to be great. We will have absolutely the same expression as we had in the beginning. What are we going to do next? We need to remember, we need to learn two formulas from school. The first one is the difference of cubes, so a cubed minus b cubed, because we have it, a difference of two cubes. This is equal to a minus b, and times a squared plus ab and plus b squared, and we need to know a difference of squares. This is our school identity as well, so we have a squared minus b squared equal to a plus b times a minus b. Doesn't matter what the order, so we have a plus b, a minus b, doesn't matter. So we have a plus b times a minus b. And right now let's apply each of this formula into this spot, into this line. We have difference of cubes and we have a difference of two squares. So as a result, what do we have? On the left side, we have x minus 4, and of course in our parentheses we have, in another parenthesis, we're going to have this expression. So we have x squared plus 4x, and plus 4 squared plus 16. And in the second parenthesis, we're going to have a plus b, a minus b. So x plus 4, and times x minus 4 equal to 0. Right now we have x minus 4 right here and x minus 4 right here. Okay, so we can easily factor it. We can write it in the beginning. So we have x minus 4, and in another parenthesis we're gonna have, what do we still have? We still have this parenthesis minus this one. So as a result, we have x squared plus 4x plus 16 and minus x plus 4, x plus 4 equal to 0. We can easily write it, this one inside parentheses, it's going to be correct. Okay, so equal to 0. Right now let's open our parentheses real quick and simplify our second this parenthesis. Okay, so x minus 4. In the second parenthesis we're going to have x squared, so the same beginning, x squared plus 4x plus 16 and minus x and minus 4 equal to 0. Let's simplify this. So what do we have right here? We're going to have 4x minus x. We have this expression with x as a common expression, and we have a constant, so 16 and 16 as 4. As a result, our final expression when we're talking about factoring, we have x minus 4, and in the second expression we have x squared 4x minus x plus 3x and plus 12. 16 minus 4 plus 12 is equal to 0. And right now a great moment, because a product of two parentheses equal to 0 when the first parenthesis equal to 0 or the second parenthesis equal to 0. So let's start with the first one. So the first parenthesis equal to 0, x minus 4 is equal to 0. And from here our x first is equal to 4. This is our first root. We're going to check this root a little bit later. Let's solve this second parenthesis. So we have x squared plus 3x plus 12 equal to 0. This is a quadratic equation. We can easily solve it with the all-known method, with the basic method, for example, with the method of coefficients. So a equal to 1, b equal to 3, and c equal to 12. And let's find real quick our discriminant. So our discriminant is equal to b squared minus 4ac. As a result, we have b squared, so 3 squared minus 4 times 1 times 12. From here, our discriminant is equal to 9 minus 48 equal to minus 39. This is our discriminant, and it means that in this moment, at this point, at this second part of this parenthesis expression, we're going to have two complex roots. So let's plug in each of these elements into this spot. When we're talking about our root, x second and third is equal to minus b plus minus square root of discriminant and all over to a. Let's plug in each of these elements into this spot. Minus b, so minus 3, plus minus square root of discriminant, square root of minus 39, and we're going to divide it by 2a, 2 times 1. Let's simplify this a little bit, because we need to find our I expression with I. Okay, so we have minus 3 plus minus. Instead of this minus 39, let's write a product minus 1 times 39. We can write it like that. We can write it as a product, okay? Write it as a product and divide it by 2 times 1 equal to 2, okay? The next thing we're going to do, we can easily split this square root, okay? We can write it as square root of minus 1 times square root of 39. According to a basic square root property, this property looks like that. We can easily underline it real quick. So square root of a times b, we can write it as square root of a times square root of b. We can easily split it. So let's continue it right here. So we have minus 3 plus minus square root of minus 1 times square root of 39 all over 2 equal to, okay. As a result, what do we have? Minus 3 plus minus square root of minus 1 equal to I times square root of 39. Square root of 39 without any changes. We can't simplify it. This looks like a prime number, I guess, but we can't find square root right here quickly, because this is not a table case. Okay, and we divide it by 2. From here, what do we have? Minus 3 half plus minus this expression going to divide it. So we can easily split it like a real part and the imaginary part. This is up to you. This is how do you want, how does our answer looks like. So we can write it as minus 3 half plus minus I square root of 39 over 2. This is up to you. How do you want? You can easily leave it like that with the two answers, x third and x second and third, or you can split it like a real part and imaginary part. This is also up to you. Right now you can see a graphic on this points of intersection. You can see this like question from geometric perspective. Yeah, but right now I'm going to write real quick our answer, and then we can easily check, for example, 4. Okay, our answer to this question. So x first equal to 4, x second, let's write to, for example, with the positive sign, so minus 3 half plus I square root of 39 over 2, and the third root, so x third is equal to minus 3 half minus I square root of 39 over 2. So we have our answer. These two roots are complex root. This one is real number root. So this is great. So we, as you can see right here, we solved this question. We can easily check real quick our x equal to 4. We don't need to check these two complex roots, because it will be like a long video, and we don't need to do it every time you need to solve this question. You can easily, in the end, you can easily check a real number root real quick. In the beginning, what we had x, x square, I guess. Yeah, if we have x cube minus x square equal to 48. This is our equation from the beginning. When we plug in 4, we have 4 cubed minus 4 square equal to 48. And this is a correct expression. We have 64 minus 16 equal to 48. So everything is great. And you know, a lot of students might be thinking, okay, mister, we can easily solve this question by inspection. Yeah, we can easily guess a root from the beginning by inspection method. And I say, okay, this is a great moment, but how can you solve this question? How can you find, for example, these two complex roots? This is absolutely impossible with inspection method. There is no way you can easily get in a few seconds these both roots, x second and third. Of course, you can find x first equal to 4 in a few seconds, and without any doubts, this is a great thing that you can solve this question by inspection. But if you're talking about a full solution, because we have x cubed, so it means, according to a fundamental theorem of algebra, it means that we have 3 roots in total. We don't know how many real number roots, how many complex roots, but when we have one real number root and equation looks like x cubed, it means that with a 99% of probability, you're going to have 2 complex roots, maybe 1 complex root. I don't know how this equation looks like, but in our case, we have x cubed, so 3 roots in total, 1 real number root and 2 complex root. So this is my solution to this question. I really hope you understand it. I really hope you learned something new. You can also write your notes, write your response, write your thoughts about this question down into the comment section. It's also really interesting to read about it and to exchange a little bit about this mathematical Math Olympiad question. So thank you everyone for your time. Wish you all the best in your life. Take care of yourself and have a great day. See you in the next videos.